1, 2, 3. There it is. Okay. So let's come back together now and see what ideas or what questions came up. So the way I'm going to do this is you all have ideas right now because you just turned and talked to each other. So you either have your own idea or your neighbor's idea. I'm going to start with the cards, and I'm going to call on a handful of cards to add to our list up here of your ideas or potentially your questions, things you want to know. Then after we go through some of the cards, then I'll leave it open for hands so people can volunteer ideas that haven't been shared. Okay? So let's see what you came up with. Christy, what did you come up with?
We were thinking that the chemical makeup in water and ethanol has to be different. We know that water is H2O, which is 2 hydrogen, 1 oxygen. And we weren't really sure what it is, but we also know that oxygen can burn. When we start a fire, we know friction also would help with that. Energy transfer from the fire of lighting it to the oxygen, maybe?
Say that last part again.
So the fire we're using to light it.
So this part here.
Yeah, that's one energy. It sort of passes on to the ethanol.
Okay. So the energy that's coming out of this lighter right now, when I light the ethanol here.
Chemically it reacts and...
Okay, so I lit the ethanol, so I just pass some of the energy into the ethanol. That's what you're saying? Okay.
It did. You need to focus your eyes.
No, it just takes a little while to get rolling. There, can you see it now? All right, so the lighter
So funny if we had another fire.
passes energy to ethanol. All right, so just to make sure I caught everything, because Christy had a lot of great ideas there to share. You told us about water, how it's H2O, so you're thinking there might be something else in the ethanol. Is that right? So something in ethanol. And then you said there's something about oxygen being able to burn. Friction helps with this somehow, and then the lighter is passing energy into the ethanol. Did I capture? Yeah? Okay. All right. Lots of ideas to get us started there. Let's see what other ideas are out there. Alex. Yes.
We were thinking that there should be carbon in ethanol.
There's carbon in ethanol. Okay, so you're thinking there's carbon in ethanol.
And that would be the difference between the water.
Ah, okay. So that would be the something else. Now, tell me though, carbon, so this one's got H2O, hydrogens and oxygens. What do you think is so special about carbon? Why would carbon make it burn?
It's a byproduct of fire.
Okay, so carbon is a byproduct of fire. And what I just heard another.
Fire gives off CO2.
Oh.
So the CO2 is C, and the CO2 is carbon.
Oh, okay, there we go. So carbon is a byproduct of fire, and you're saying that byproduct is the CO2?
Like when you burn something, the carbon is taken out of it burning and becomes CO2 and mixes into the air.
Okay, so that the CO2 is coming out from the fire somewhere and going into the air. Okay. Any guesses where the carbon dioxide is coming from? From this table here, they were talking about carbon dioxide. Where's that carbon dioxide come?
Like the carbon is from the thing that you're burning, and I think the O is oxygen, and it would be from the air.
Okay, so you think the carbon is coming from the thing you're burning, so in this case it was the ethanol. And then you're thinking the oxygen is from the air around it?
Yeah.
Okay. Okay. Awesome. I'm going to do one more card, and then I'll come around to some hands that I sort of see flickering up now. Riley, any other ideas or any questions?
I mean, everything that we had to say is pretty much.
Okay, so you got this. Do you have any questions, anything that you're like, if only I knew this, that would really help me figure out what's going on here?
What is the difference between
Less.
Say it again?
Oh, I was just.
No? No? Okay, you can pass on that. All right, let's, okay, I'm gonna put cards down. Other ideas, other questions. We'll go to hands now. Got a lot of ideas, not a lot of questions. which kind of makes me think you feel like you got this sussed out, you got this figured out. So let's see here. Who we heard from you? Lisa, I don't think we've heard from yet.
Why, if there is carbon in it, then why would it burn if it's a byproduct?
All right. So why would it burn if it has carbon? If carbon is a byproduct. Is it BI or BY? BY. Okay, thank you. I thought that was looking kind of funny. All right, so you're kind of wondering what's going on. So you're sort of back to that question, what's so special about carbon? Is that right? Am I capturing that right, Lisa? Okay. So what's special about carbon? If that's just a byproduct, that still doesn't tell me why does carbon help it burn? So there's a question there. TJ, what do you want to add?
I want to know like what exactly like on a molecule level like fire is.
So what is fire at a molecular level? Awesome question. All right. What is fire at a molecular level? That's exactly where we're going to be going. Awesome. Nice. Rena.
It kind of makes me think to, I think it was like World War or something, where they were making the hydrogen bomb and they were worried that it would ignite continuously with the atmosphere. So it makes me think of that.
Okay. So an idea here. So where do you want to put like as an idea of?
Like questions, like what's the difference?
So you're wondering what's the difference between this and like the hydrogen bomb? Okay. Between burning ethanol and H-bomb. We're thinking about World War II here. Okay. Let's see here. Yeah, and we'll come over right.
CO2 is absorbed by trees, and I'm pretty sure it uses energy, but some maybe stored because, CO2 intake, oxygen output. So perhaps ethanol contains something that was once, to use a scientific term, organic, that grew naturally.
So hold on back. So you're saying the trees are saying take in CO2 and make O2. I caught that. And then what did you say about, what was it that came after that? Because I couldn't quite hear you.
Well, it seems that if most things, like trees and plants, do photosynthesis. So, I lost my train of thought. Basically, maybe ethanol contains something that was once growing and living as opposed to water which did not.
Oh, okay. There we go. Thanks. So ethanol contains something that was once living. Water does not.
Kind of like how oil can be used for energy and fuel, because oil is
Awesome. All right. So an interesting idea there. The magic ingredient in ethanol that maybe is helping it burn is that it has something that was once living. Water doesn't have that thing in it perhaps that was once living. So an example of this is that oil can burn, which is fossil fuels. Fossil fuels were things that were once living. So now you're trying to think to this like what's alive, what was living, the idea of organic, which we're getting to. That's awesome. Nice. Cool ideas there. Going on to Riley.
So what are the distribution levels of oxygen and ethanol to create the fire?
What do you mean by the distribution of them?
Like what percentage is oxygen, what percentage is...
Okay. So are you wondering like how much oxygen do you need to burn ethanol? You need of oxygen to burn ethanol. Cool. Coming around, Isaiah?
What's in ethanol?
What's in ethanol? Yeah. Let's just like go back to the basics there of like what is in there. Awesome. Coming around, TJ?
I think that maybe if we look at like what happens, like if what happens to the molecules when they burn, like we can like figure out like which molecules or like cause things to burn.
Okay, so you're kind of wondering what is the whole mechanism of burning? So if we understood what it means to burn, then we can figure out why some things burn and some things don't.
Yeah, and,
Am I capturing that?
Yeah, like if you like figure out like what happens, like how things transform when they burn, then we can figure out like why some things burn and some things don't.
Okay.
Maybe something is stronger.
So how do things transform? I heard you say. I like that word. When they burn. So if we knew that, then we would know why some things burn and some don't. Nice, thanks. Zach, right? Yeah, all right.
Does the molecular density of an object affect its burning?
Ooh, put that up there. Does the density of an object affect if it burns? Wow, you guys took off on the questions now. Other questions, other ideas? Everything's welcome right now. I'm putting everything up here. Okay, awesome. That's a really solid list. I'm really impressed, guys. You really start to dig deep there to try and figure out what's going on here. You're pulling in ideas that you have from outside of class, which is great. You're coming in here with a lot of ideas and a lot of experiences, so I'm happy to see you bring those ideas in. So what I'm going to do is take a picture of this and document it, and we're going to come back to this to see how your ideas change, and then also see if we can answer these questions as we plot on through this unit. But where we are going next is not everybody got a chance to talk there. I know it's early in the year. We're still a little shy, some of us. So right now, I'm going to give you an opportunity to write down your ideas. You're expressing ideas of what do you think is really happening when ethanol burns. So that's getting at that kind of that mechanism that TJ was talking about. What's really going on when something is burning? Oh, thank you. So I'm going to give you 5 minutes on your own to answer the questions on this pink sheet. So pink, we're at the beginning of the unit. These are your ideas to begin with. I know you don't know all the answers yet. This is just what you think. So all answers are welcome. I would really appreciate it if it was sort of silent time, 5 minutes, looking at that flame, what's going into the flame, what's coming out of the flame, what's going on there. If you can explain what's happening when something burns. People have been struggling with their explanations because they're just not sure. Then they've been focusing more on the questions that they have. What do they want to know so they can better answer that question? I just floated around. I looked over a lot of shoulders. There are some cool ideas of what you think is going on. You guys know a lot already about what's happening when something burns. You know some of the things that go in. You know some of the things that come out. We've got a lot of really cool ideas already here. So here's what we're going to do. I would like you to compare your ideas with a neighbor. So you're going to partner up with one other person at your table. The only exception to this should be our one table group of 3. Otherwise, I want 2 conversations going on at each table. So you're going to partner up with one other person at your table, and you're going to take turns reading what you each wrote. And if you hear something somebody says, your partner says that you like, you can add that onto your diagram if you want. Okay? Then I want you to each take turns reading, sharing what you're thinking is going on when ethanol burns, and then compare your ideas. What's similar about them? What's different? And then I put Post-its on your table. Write down 2 to 4 of the most important ideas you came up with on those Post-it notes, on those sticky notes. These can be ideas or questions. So what you think is going in, what's coming out, or what questions do you have about that? What do you think is going on when ethanol burns? When you're done putting together those ideas on your Post-its, go ahead and put them on this whiteboard right up here, the small one. On the left is anything for your ideas, and on the right is your questions. So to recap, partner up with one person at your table. It's not a whole table discussion, it's just a partner discussion. Share your ideas. Put your key ideas down on your Post-its, add them to the front. Let's take about 5 minutes for this. Do I have all the Post-its? Yeah? Awesome. Okay. So just at a glance, looking over these, and I'll spend a bit more time with them later on and categorize your ideas and categorize your questions, and I'll come up with a nice list of what you came up with here. What I'm seeing here on your ideas of what happens when ethanol burns, I'm seeing a lot of people make reference to oxygen going in. So it sounds like a lot of you are coming in knowing that oxygen is going to be a key player in this. I also saw in a lot of post-its there something about CO2 or carbon dioxide coming out. So it looks like a bunch of you kind of know there's something about carbon dioxide going on here. I see some ideas about heat and light coming out of that flame as well, coming out of the burning ethanol. So we'll talk more about that as time goes on. Questions. Perhaps the most common question in here is, what else is in ethanol? Okay, so there's some ideas in there about carbon being in ethanol, but what else is in there? So you guys really, it looks like you want to zoom in on that ethanol and really get a better understanding of what's inside that ethanol. Then there's a lot of questions where you just flip the question back onto me. So I'm asking you, what happens when ethanol burns? And then the questions I see on there, you tell us, Ms. Newell, what happens when ethanol burns? So, and that's where we're going. Like, I'm asking you, you're asking me, we're going to work together on this to come up with our answer to this question about what happens when ethanol burns. But just like your post-its are identifying here, you guys are ready to take it from this macroscopic scale and zoom in and really see what's going on in that ethanol. Get a better understanding. It's not just this clear, colorless liquid. There's something else in there. What is it? And unfortunately, our microscopes aren't powerful enough to get us to that level. We have to go even deeper, zoom in even more. So what we're going to do is be going back and forth between these scales of macroscopic and atomic molecular. That's even beyond microscopic. We're going in even deeper, the atomic molecular scale, in order to answer our question. So a lot of you hit the nail on the head. You got to know what's in there to understand what's happening when ethanol burns. So here's this roadmap again, just to show you where we're going. So you can see we're making some progress here. We started off right there. We did our pre-test. We've established the problem that we don't really understand what's happening when ethanol burns or why ethanol burns. So now we're going to move forward a little bit. And we're going to this orange bubble, which is your foundational knowledge, some background information that you need to really have a deeper understanding of what's happening when ethanol burns. Okay, so that's where we're going. We're almost up to an investigation, which is what we'll do next week. So the information we need is understanding scale. So we're going to move on now to this idea of powers of 10. And so we're looking at these different benchmark scales